We will now use a LoRaWAN network. It requires a bit more configuration than with Sigfox because you need to manage multiple operators. Your object has an identifier, the devEUI, which is 64 bits. The LoRaWAN _dev I.py program will display it. Now each operator will have its network gateway, or LNS, LoRaWAN network server, which will need to be configured to accept our object and send back the information it produces. We will need a 128-bit secret that will be shared between the LNS and the object. We will also need an appEUI to identify the running applications, but its usefulness is limited. Once this information is known by both the object and the LNS, the object will send a join request containing its identity and authenticated with the secret. As always, it will be received by all operators covering the area. One of them can recognize the devEUI. It contains and verify the signature. If the request is valid, after 5 seconds the LNS returns a join accept message that will provide a reduced size address of 32 bool bits, which will be used in subsequent exchanges. The join accept message will also allow the object to create the same encryption key as the LNS for the communication session between the object and the LNS. The LNS must also be configured to transfer the data it receives to an application called, in LoRaWAN terminology, application server. So, on the object side, 3 pieces of information are needed: the devEUI, which identifies the object; the appEUI, which is used to identify the application; and a secret on the LNS side. We also have the devEUI, an associated secret, and the connector to where to send the data. We will detail several LNS configurations because the logic is not the same depending on the operator.